YouTube channel of my twin brother, Jack here. He's obviously the YouTube expert, likes to edit and make YouTube videos. So it's any silly behaviour on his part is not to be attributed to me. Okay folks, so we're ready to upload our file. Unfortunately, I have run out of USB connectors on the front here, so I'm going to have to go around the back of the Mac. But what we're going to do is we're going to take our cable, sorry, we're over here with the camera, take our cable which we used last time, we're going to plug it into the Arduino. And I haven't got batteries in this at the moment. I've also not got the positive power connected, so I've actually improvised a little bit of a switch, which basically what I did was I put the positive lead in, I'll just show you here, positive lead in here, I ran it to the breadboard, and then what I did was I've then got another cable here, so you basically create a circuit via the breadboard. Or you could put a switch there if you liked. Really, it's up to you. At the moment we haven't got any batteries in it because the power we'll need to actually program the Arduino will come from the USB port, so we don't want the thing taking off once the sketch loads anyway. So I'm just going to get up and I'm just going to plug this in the back of the computer, and we will be ready to upload our sketch. And here we go. We've plugged it in. We're going to open up our, we'll just see if we can we might actually be able to see the screen at the same time. How about that? Okay, we're going to open up our Arduino page. We're going to go to our libraries folder, if we can find it. Sketchbook, libraries, obstacle avoiding robot code. Up it comes, and we're going to hit upload, and fingers crossed it all goes like it's supposed to. Okay, it's saying you can't find the port. So this is what they warned us about before. So what we need to do is we need to make sure that we're actually on the correct port. So we'll go to board. Yep, the Uno is selected. Serial port. We actually have to I think we need to go to the second one, if memory serves me correctly. And let's just try it again and see if it'll behave itself this time. Hit upload. And it's already starting to do something because I think it's getting power from the USB, which is very interesting. So what I'm going to do now is I'm just going to unplug our USB, and I'll just shut this down. Quick, out of here. You can hear the motor chattering away. And now it'll die, of course, because we haven't got power connected to it. What I'm going to do is I'm going to get out my batteries, and we're going to give it a test and see if it behaves itself. Stay tuned, hopefully we're getting somewhere. Okay, so we're just going to put our batteries in now, and hopefully we get something happening. And if we don't, this is when the whole fun part of electronics starts, and we have to start troubleshooting why things aren't working as they should. So, battery case is on the bottom. You got to make sure these are polarized correctly. This makes for a total of 5 volts, which, like I was saying before, I don't think is going to be enough to actually power this robot, but we shall see. So, like I was saying, I need to plug this in here, and then hopefully something happens. And something's happening, but not very much. Wheels are going backwards. Okay, let's have a look. As we can see, my robot is going around and around in circles. Now, let's make an assumption that both wheels are supposed to be driving forward because it hasn't got an obstacle in front of it, which means that because it's a DC motor, we need to switch one of the wires around on one of the pairs of wires on one of the motors. The one that's going backwards needs to be going forward. So we'll work out which one's going backwards and we'll swap the wire around. I just want to quickly have a check to see if I go in front of the sensors whether it behaves differently, and that will tell me whether the sensors are actually working. So let's just get in front of the sensor and see if it does anything different. The wheel has stopped, which is interesting. So let's just assume both wheels are going backwards. Okay, we already have a mechanical problem as well. So I put the screws through and they're actually touching the wheel. So let's cut the power, and I've put these screws through, and as you can see, if you look in there, they're actually touching the wheel because I put them through one way on one side and I should have gone the other way on the other side so that they don't actually hit the wheel. So that's an interesting little development that needs to be fixed up because I didn't realise that those bolts would be so close to the wheel. Anyway, we'll sort that out and we'll come back and we'll see if we can get this going. But it looks like it's reasonably promising. Okay, folks. Well, as you can see, the motors are spinning in opposite directions. This bottom one is spinning in the correct direction. Which would be forwards. This one's going backwards. So we need to swap the wires, and the wires coming out of this one are the brown and the orange wire. So we swap them on the motor controller block here, and we know the sensors are working because when I put my hand in front of the sensor, just listen to the motors. It stops. The bottom, watch what happens. The bottom wheel is spinning, and when I go like that, something happens. Just try and show you this from here. So I do think this is grossly underpowered, but what I'm going to do is I'm going to swap those wires around. I'm going to cable tie up some of these wires so they're not in the way. And then what I think I'm going to do is I bought a couple of 9-volt batteries, which I think I'm going to parallel up, and I'm going to sit on top here. We're going to maybe give this power a little bit of assistance. Soup it up a little bit. Hopefully we don't blow anything up, but I think 9 volts should be still an acceptable voltage for the Arduino. I'm going to quickly look that up. But yeah, we want to basically on this block here, on the motor shield, these 2 pins here, the top 2 pins, drive that motor. At the moment, they're driving it backwards. So I'm going to just swap them around. So we'll just bear with me for 1 second. I'll just take those 2 wires out and swap them around. So the brown will be the second wire rather than the first wire, and the red will be the first. So brown goes to number 2. Okay. So we pop them out. You pop the red one back into the first slot, and then we put this brown in the second slot, and it should be fine. No, that didn't go in. This is when Mr. Commodore should have his glasses on because he's going blind. Okay. bear with me. I'm trying to get this so that you can actually see what I'm doing. But yeah, red goes into the number 1. So a DC motor, basically the direction it spins in is dependent on where the positive and where the negative terminal are connected. So if you want to spin one way, you'd put red on one and black on the other. And then if you want to spin the other way, you just reverse those 2 wires. So it kind of makes sense in its own way. And presently I'm just struggling with this connector because it doesn't seem to be opening up like it should. Just make sure that that's actually popping up, which it is. Okay, that's in now. I'll just tighten it down. Hasn't made a good connection, unfortunately. It's better. Then we need to get our black wire in, so our brown wire, and then we'll have a look and see whether that's made a difference. We hopefully then have wheels that are spinning at least in the same direction. Now, to get these wires to pop in more easily, we could actually tin them with solder. It would make our life so much easier, but at the present moment I'm just trying to complete this project without the use of a soldering iron, just to prove to myself that it is possible. And obviously the more equipment you have, the easier things become, but I want this to be a project that's possible on a bit of a shoestring, so that's why we haven't used a soldering iron. Okay, so let's plug that power back in again and just see. Okay, now it's driving forward, so that's a good start. Both wheels are turning in the same direction. And I think almost at the same speed. So let's pop it down on the ground and just see what it does. Off it goes. I'm going to just grab an object and see if I can get it to turn. Oh, it stopped. But is it going to do anything? I think the motors aren't strong enough. It's trying to turn, but gee, gutless as. Yeah. So it is responding, but yeah, it's juddering, which usually indicates there's not enough power. So what we're going to do is we are going to suit this up with some 9-volt batteries in parallel, so they can provide the voltage provides the correct voltage that we need, but we also need enough current to drive those motors. So we're going to put them in parallel. I'm going to show you how to do that. We're probably going to take those 5-volt batteries out. You could use them to power the Arduino separately, but I think what we're going to do is just get 2 9-volt batteries and see if that makes any difference to the way it operates. I'll be back with you shortly to show you how to do that. Okay, so like I was strongly suspecting, grossly underpowered, what I'm going to do is I'm going to pop out these batteries. Now, you may get a more successful sort of power output by soldering all those wires too, making a better connection. But I strongly suspect that that's still not going to get us across the line. You could probably buy better quality batteries too. I bought the cheapest batteries money to buy. So if this doesn't work, I'm definitely going to perhaps go to a better quality battery. These were reduced to $2.50. That's the 9-volt batteries, which are normally about $7 or $8. So chances are this may not work as well. Once again, if you try and save money, I'll just get the apple cider out of the way. If you try and save money, it doesn't always work. So what we're going to do is we're just going to do a parallel connection. So what's a parallel connection, you may ask? Well,
if we took the batteries and we went positive to negative to positive to negative in that order, that's called a series circuit, and each of those voltages would add up. So when we had 4 of these 1.5 volt batteries, you end up with 5 volts, because you've got 4 volts plus 2.5 volts makes 5 volts. So those lined up in that battery holder makes a 5 volt circuit, but it doesn't give you a lot of current. So what we're going to do is we're going to up the voltage to 9, and I don't know whether these actually provide more current, and I actually haven't had a good look or good think about it. But what I'm going to do is I'm going to strip the wires, and instead of going positive to negative, because then we'd end up with 18 volts, we're going to end up with 9 volts, because we're going to go positive to positive, negative to negative, and that means we've got 9 volts, but we've doubled the current. Okay, so I'm going to show you how to do that. We've got these battery holders for 9 volts, which I purchased at J-Car today, and we're just going to strip the wires so we can twist them together. Be careful we don't actually destroy our battery holder, because that would be a disaster. That's one stripped. I'm going to strip both of them. We're going to twist them together, and we're going to feed them into where that 5 volts was going in before. And then we're hoping that that will get us, I just broke the wire, that will get us across the line power-wise, and the thing will behave like we're expecting it to behave. And then we can start looking at, you know, maybe programming it to do something really simple. So there we go. They're the 2 wire strips. So we go red to red. That's positive to positive. Let's twist them together. And we go black to black. So what I'm going to do is, because what I had here was I had the positive from that battery case coming out there. What I'm going to do is I'm going to, this will feed in here. So what I'll do is I'll take my positive from my 9 volt batteries, and I will feed it in part of the breadboard here. I'll just show you what I'm doing over here. I'll just feed it into the breadboard just here, because what I'm basically doing here is I'm making a very makeshift switch. It's just a way of creating a switch, so we can avoid buying a switch. We've got a breadboard here. Okay, we can't poke that in there, so what I'm going to do is, I'm going to be even clever about it than that. I've got a whole load of these breadboard wires. So we're going to take one of these wires, strip it. We're going to use it, and we're going to twist it around positive, and then we're just going to tape it up so that it's insulated so it doesn't short anything out. So there we go, twist, twist, twist. So that's going to be one part of the switch. Get a bit of masking tape. I'll be very interested. I should probably check to see whether the Arduino can take 9 volts, but I'm pretty sure it can. It's quite a forgiving piece of technology. Okay, so the black wire will go where the black wire went originally for the battery holder. And what we can do too is, because this battery holder is no longer being used, we can get rid of it. So we'll do that as well to lighten the load a little bit. So once again, same deal on the motor control unit. The black wire goes where it says ground. Now that whole experiment answered my question about whether the motor shield provides power for the Arduino, because the Arduino was working, the sketch was operating, and the robot was working. Only problem being, of course, as we noticed, was that power was a little bit light on. So hopefully this is going to be a fix for the whole situation. So we shall see. I'll just screw this down. So that's the earth wiring. We'll then grab our That's our positive wire. That can go in one side of the breadboard. I'm going to tidy up some of these wires because they're starting to annoy me with just a little bit of a cable tie so that they don't snag on anything. That's it there. Sorry, I'm just going to show you what I was doing now. I just cable tied the wire up, gave a bit of a haircut, a bit of a ponytail. And we're going to remove that battery holder now because it's superfluous to our needs, which is good because when I actually order the kits for the students at my school, I won't bother with this battery holder. So we're going to put our batteries on our holders. That's one. Two. And then we're going to, we'll probably eventually double-sided tape these on, but for the time being, I don't know, we can just use a bit of tape for the time being, just so they don't rattle off when the thing's trundling along. So a bit of tape, and we need to be able to get this one into the actual breadboard, so we'll probably tape this one closer to this side. Now, fingers crossed, when we plug this in, we'll start driving forward a lot quicker, and it behaves itself. Let's have a look. Oh, looking good. And let it go. Oh, let's see if it, oh, yep. Come on. Yep, negotiated that obstacle all right, it's coming back. Oh, chair, I don't know if you can handle a chair leg, too narrow. Didn't like that. So obviously this code can probably do with a little bit of finessing. Let's see if we can avoid a really simple object like that. Yeah, it's trying. Yeah, it's turned around. It doesn't like narrow objects by the looks of things. So definitely that's a problem. But let's see what it does here. Yep, that's turned alright. Oh, run itself into a corner. I'm going to go rescue it before it burns out. This is definitely not working now. So this is a great opportunity to investigate the code and just work out how we can change some of the parameters to get it to stop a little bit earlier before an object, so that, because at the moment it seems to be running into objects before it can actually do its avoidance characteristics. So we shall have a play with the code in this, open up the sketch, and try and get it to behave a little bit more predictably, because I mean it's promising, but it seems to be a little bit slow in reacting. So I've just had a look at the code, and I've noticed it's obviously going to have difficulties with very skinny objects if the ping sensor doesn't pick those things up. What I've done with this with the design too is I've just placed the sensor lower so that it's not going to miss lower objects. So obviously positioning of the sensor is quite critical. And I've also gone into the sketch. I don't know very much about Arduino programming, but just from that little bit of stuff that I did learn when we did the blink test, was a demand called delay. So I've gone into the code and I've looked at the explanations of what each part of the code does, because he's written quite good explanations. And even though I don't understand all of the demands that are there, I do know about a demand called delay. And if you set the delay and then put in brackets the amount of time as per the blink, where you get the LED to turn on and off, which we discussed previously when we were talking about programming the Arduino, you can get a delay of, well, if you set to 1,000, it's 1,000 milliseconds, which is 1 second. So what I've done is I've basically changed the code for this robot now, so that when it encounters an object, rather than just trying to turn on the spot like that, what I'm getting it to do is I'm getting it to go backwards for a second and then turn. So it's kind of like backing away from the problem. I've also set the delay to the object a little bit higher. So it still has problems with skinny objects and objects that are that miss the ping sensor. But I'll just set it down on the floor and I'll let you have a look at how it goes, and you can judge for yourself whether it's better or not. So I'll let it go. When it encounters an object, like me, backs up and moves away. It's heading towards another object. I'm just going to try and corral it here. It sees me and it backs off. It sees me and backs off. Sees me and backs off. Let's let it go now and just see whether it's, of course it goes to the skinniest object in the room. Oh, yes, it's missed the chair. It's going to come back into the field of view. Yep, here it comes. You're going to see this? No, it's not going to see it. It's run into a very skinny chair leg. We'll just set it off in this direction. Oh, it's actually seen the chair leg this time. Will it come back into our field of view? Is the question. That's the sort of thing that's a problem, because it's not going to see anything that's above it. So you could have sensors facing, or an array of sensors programmed so that it would see objects like that, but it's always going to find that object a problem. It just goes to show you how difficult it is to program a device to miss every single object in the room. How amazing it is that Google can make a car that can drive itself.